This video clip is about writing equations from table data. So if I have this table of data, I could plot those points. Let's say this is our x-axis, this is our y-axis, and each square would be 1. So go over 2 up 1, over 4 up 5, and over 7 here's 5 over 7 up 11. So here's 5. So up here somewhere. Yeah. And if so, to get from this point to this point, I go up 1, 2, 3, 4 over 2. So to go the other direction, instead of going that way, going this way, I would go back to down 4. 1, 2, 3, 4. Right there. So if we try to write an equation for that line, we look and see where it crosses the y-axis. That is at -3. So the intercept equals -3. It intersects with the y-axis at -3. And then we try to figure out the slope. The slope is up 4 over 2 to get from one point to the other. Well, that 4 divided by 2 is 2. So the equation is y equals 2x minus 3. That's a graphical way of finding the equation for a line. There is a mathematical way. Let's do that one. So the difference between 5 and 1, 5 minus 1 is 4. The difference between 4 and 2, 4 minus 2 is 2. 4 divided by 2 is 2. So I know y equals 2x plus something. Then I can plug in one of those points. The easiest point is probably 2, 1. So 1 for the y, 2 for the x, 1 equals 2 times 2, which is 4, plus something. Subtract the 4, just solving now. So -3 equals b. So I know that y equals 2x minus 3, which is the same as we got using graphical methods. Remember that one back there? Y equals 2x minus 3. Works either way. You can choose how you want to solve these. There's graph paper available. Let's do another one. 1. Oh, we'll have each square be 1. And over 1, down 1. So that point right there. Over 4, down, up 2. Over 8, up 6. Well, so going from this point to this point, I go up 1, 2, 3 over 3. So 3 over 3, that's the same as 1. Well, that makes sense. Up 1 over 1, up 1 over 1, up 1 over 1. That's the same slope. And then if I go back 1, down 1, I cross the y-axis, and that is at -2. So I know y equals 1x minus 2. Why not just write y equals x minus 2? That's how it's usually written, is without the 1. Mathematically, 2 minus -1, subtracting a negative is the same as adding, so that would be 3. The change in y is 3. The change in x from 4 minus 1 is also 3. So my slope is 1. y equals x plus something. Plug in a point. Any point will do. So 6 equals 8 plus something. Solving. 6 minus 8 is negative 2. So b equals negative 2, y equals x. I could say plus negative 2, but adding a negative is the same as subtracting, so let's just subtract 2. Go to negative 3. Oh, I need to label these. Each square will be worth 1. And we go to negative 3, negative 6. 1, 2, 3, 4, 5, 6. 2, comma 4. 4, comma 8. So to get from this point to this point, we go up 1, 2, 3, 4 over 2. Slope is 4 over 2, which is 2. And then if I go back to down 4, that point is also on that line. That value of that point for y is 0. So I know y equals 2x plus 0 for the y-intercept, but it is usually written as y equals 2x because adding 0 doesn't change anything. The difference between 4 and negative 6 on a number line is 10. So 4 minus negative 6, that's looking for a difference, is 10. And going from 2 to negative 3, that's a distance of 1, 2, 3, 4, 5. 10 divided by 5 is 2. So the slope of that line is 2. Y equals 2x plus b. Plug in any point. Let's pick this one. So 4 equals 2 times 2 plus something. 4 equals 4 plus something. Subtracting 4 from each side says that b must be 0. So y equals 2x plus 0, or just 2x. That's what we got graphically.